Welcome to NASA's Summer of Innovation lesson videos. I'm Kat Balch with NASA's Aerospace Education Services Project. Today I'm going to walk you through building the high-power air rocket launcher. This lesson plan can be found in the Educator Rockets Guide. This video is just for the rocket launcher construction and safety. There is another video about the two different activities you can do with your students using this launcher, the high-power paper rockets and the advanced high-power paper rockets. Don't be intimidated by building this rocket launcher. You will be surprised how easy this is. I spent more time going to the hardware store getting the materials than actually assembling this. There are a lot of great reasons to build paper rockets with your students. It teaches design and problem-solving skills and is a great introduction to later on building water bottle rockets or engine rockets. It's also relatively inexpensive. If you already have a bike pump, all the materials are less than $75, and the rocket launcher should last you for many years. Included in the lesson plan is a handy shopping list that you can take to the store. I took the whole lesson plan, the shopping list, and the diagram with me. It helped a lot when I had questions. The only thing that you will need that is not included on the shopping list is a saw for cutting the PVC pipe, a drill, and a bike pump for launching. I also felt it was helpful to have a jar grippy for twisting pieces into place. Now, my store only carried the Schedule 40 PVC pipe, which is required for durability. So double check that you're getting the higher Schedule 40 and not the lower grade 20 PVC pipe. There's a note on the shopping list that you might have to special order the pressure operated relief valve. I was able to find it in the hot water tank section. This is an optional item, but it is recommended for added safety. It will be tempting to purchase the cheaper PVC version of the ball valve, but for durability and safety, purchase the more expensive brass version. Now, I did have to make a repeat trip to the store because I had purchased one of the pieces going in the wrong direction. So while you're at the store, do a quick double check that each piece fits into the next. Now, these parts both have the same name, but as you can see, they are very different. Well, that's it for supplies. Now that you have everything purchased, let's start building. First, you're going to drill a hole off-center of the 2-inch cap. This will be for the tire valve to fit through. You'll want to be sure that the drill is slightly off-center. There's a little tiny molding impression in the middle of the cap, and so that makes it the weakest spot. So for durability and safety, be sure your valve is just slightly off that of the molding imprint. The hole should be smaller than the diameter of the tire valve, and just push and wiggle it in as far as it will go. It's very important to get a tight seal. Next, cut the 2-inch PVC pipe. You will need two pieces 8 inches long, and the other piece is 15 inches long. I had to use a saw for this as the pipe cutter I purchased was not big enough to cut the 2-inch PVC pipe. While you're in a cutting mode, go ahead and cut the 1/2-inch pipes to make your launch stems and your launch rods. You will attach them later. Now, you're going to need a total of 4 pieces, 2 that are 12 inches long, 1 that is 24 inches long, and 1 that is 36 inches long. Now, for this video, I didn't make the 36-inch long launch rod, but you can decide if you want to make that with your students. Now we're ready to start assembling. Now you can purchase a clear primer. I chose to use purple so you would see where the primer and cement need to go. The primer takes about a minute to dry before you can cement. Now be sure you have adequate ventilation, and once you start cementing the pieces, work quickly. The cement dries very fast. Now you're going to start priming and cementing the 2-inch pieces of cut pipe to the center T as shown in photo 3. Repeat the priming and cementing process with the tire valve cap on the one end of the 8-inch length. Then prime and cement the 2-inch connector to the opposite end from the tire valve. Then prime and cement the 3/4-inch flush bushing to the 2-inch connector. See how it all fits together in photo 3? Now we are ready to install the safety valve. I found the directions in the lesson plan at this point to be a little confusing, but what you're basically going to do is wrap the safety valve with 1 layer of Teflon tape and then twist it into place in the bushing. You can go back and reseal the outside of the seam if you need to, but you're going to want to make sure this seal is airtight. Now we will start priming and cementing the pieces along the bottom of the T. You will first attach the 15-inch long PVC as shown in picture 2. Then to the 15-inch long piece, prime and cement your 2-inch connector piece. Then you're going to prime and cement your 3/4 inch flush bushing piece to the connector as shown in picture 4. Now we're going to attach the brass seal. So wrap the Teflon tape around the brass seal and then twist it into the bushing. I felt this is where the jar grippy really came in handy. Then you're going to wrap the other side in Teflon tape and twist it into the ball valve. You're going to want to twist and get them as tight as you can and as far in as you can. You may need to go find Popeye or someone really strong to screw this in all the way. But if there's any space, tiny space left, add a bit of the Teflon tape to make a complete seal. Next, you're going to lightly screw the 3/4 inch to 1/2 inch male adapter into the end of the valve. Now you're not going to want to seal or cement this or get it real tight, as this needs to be able to be removed for storage. Then to that adapter, you're going to go ahead and screw your 12-inch long PVC pipe. This is the piece that you cut out earlier. Now to the end of that piece, you're going to prime and cement your 1/2 inch elbow. Then finally, you're going to twist together the other 1/2 inch elbow to the glued one. Now you're not going to want to thread or screw this in too tightly, as this will be the piece that you're going to use to adjust the angles for the launches. You can just refer back to these photos if you have any questions. All right, you did it! The launcher is now complete. Okay, you do have one more step. Actually, you've already cut out your 3 lengths of the 12-inch, the 24-inch, and 36-inch launching rods. So now you're going to go ahead and prime and cement your 1/2 inch adapter, one to each of the various lengths of the launching rods. Now this way your students will have a choice of 3 different lengths for their launch rods, and each will produce different launch results. All right, safety check. You're going to want to wait overnight to make sure your glue is completely dry before you begin to launch rockets. If the ball valve or the angle pieces are really stiff, you can use soap or lubricant to loosen them up. Your launcher should last you many years, so keep it stored in a cool, dry place and be careful not to drop it. If you notice any cracks, disregard the launcher. There's some other helpful hints in the lesson plan about safety and getting the best out of your launcher. All right, it's time to launch. Remember, there's a separate video about building the actual rockets. So when you're launching, you're going to want to be sure to be in a wide open area, and students not launching need to stand back. Now your rod can be tilted to any desired angle, but should not be tilted below 30 degrees. You don't want the rocket launching into somebody. Now I recommend using a bike pump as opposed to an air compressor. A bike pump helps to keep the PSI at a reasonable level, and also allows the students to work to generate the potential energy that will be transferred into kinetic energy of the rocket launch. Now you're going to have the students pump to a pressure of 30 psi. Now this is sufficient for dramatic launches, and do not exceed 50 psi. Your students are going to hold down the launcher with one hand and begin the countdown with the hand on the valve. 5, 4, 3, 2, 1. Twist and launch your rocket. After the rocket is launched, you're going to want to close back the valve for the next student. I hope you see this is really much easier than you thought it would be. Your students are really going to love making their own rockets and launching them. Thank you for joining us as we explore together in NASA's Summer of Innovation.